Hi, welcome to Coding 1001, Introduction to APIs and REST. I'm Denise Kwan and I'm a software engineer at DevNet. If you want to contact me, you can find me on Twitter at Denise T. Kwan. In today's session, I'm going to teach you about REST APIs. We're going to start talking about the REST anatomy, look into the authorization, then get into the response. I'm going to show you some REST API tools and then some real-world examples. Now let's get started. API. API stands for Application Programming Interface, and it's a way for two applications to communicate with each other. But what exactly is an API? Well, an API is an interface that exposes selected data, services, and functionality of an application. What this means is that your application can have a lot of different data, but you only want to select a bunch of them to be exposed to other applications to use it. And with APIs, it can do it in a safe manner. APIs also specify how another application can communicate with it through templates of the structure of the API. APIs are built to be used programmatically. It doesn't mean that you cannot do it manually like we will be showing you later in this session, but because they were built programmatically, it makes it easier for other applications to integrate with these applications through code. APIs have actually existed for decades, but it wasn't until recent times that the term API has gotten very popular. And we'll see why with the REST APIs later in this session. Now, what can you actually do with APIs? You can do a lot of stuff with APIs, such as automated tasks by writing a script that does a lot of your manual tasks for you, build applications such as mobile applications, browser applications, or dashboards. You can even extend the functionality of the existing application. Now let's get into the REST APIs. What is REST? REST stands for Representational State Transfer, and it is actually an architectural style for designing network applications. Now if you couple the architectural style REST with a web service, also known as REST API, you have an API framework that communicates over HTTP or HTTPS protocol. What a lot of people don't realize is that when you're loading a page on your browser, you're actually using REST API behind the scenes. What your browser is doing is that it's calling the REST APIs to the server to fetch the information that you see when the page gets loaded. REST APIs are very popular because of performance, scale, simplicity, and reliability. A lot of times nowadays, REST APIs are built into applications as part of the product and are tested as if it is a feature. Therefore, it makes it very reliable versus how it was back then where it was always an afterthought. As you will see later on in this session, REST APIs are very easy to use and very easy to learn. A lot of the old APIs had a very high ramp up to learning the APIs, and a lot of people were just not interested in learning. Now let's take a look at the REST API flow. So if you were on your laptop and you wanted to open a URL on your browser, you will type in the URL, and then when you click return, many of these API requests are being made at the same time, but this is just one example. It's going to make a HTTP request over to the server. The server is going to process this information. The client doesn't actually need to know what is happening on the server side. All it needs to know is that it's going to send back an HTTP response. Hopefully, this one will contain data, and then taking all the data that it receives, it's going to update its page with the data that it received. Now let's deep dive into the request. The most important thing about the request is the URI. You need to tell the server what you are requesting. As you can see, the URI looks just like a URL on the browser. It starts with a protocol, which indicates how the data is sent between the client and the server. That could be open with HTTP or secure with HTTPS. Then next becomes the domain name, which resolves to the IP and the port of the web service. Basically, where is this web service hosted? Next is the resource, which is the location of the data and the object that is being requested. The resource really varies depending on how the API was implemented. And lastly, there's the parameters, which is the scope or the filter of the request. Oftentimes, this is optional, and just like the resource, this varies based off of how the API was implemented. So now that you know about the URI, let's look at the HTTP methods. What do you want to do with this request? The HTTP methods maps an HTTP verb with a CRUD operation. So if you do a post, it is creating. So it is used to create a new object or a resource. For example, if you wanted to add a new book to the library. Then there's the get, which is a read, and that is retrieving details of a resource that's already in the system. So an example of that is to get a list of books that's in the library. Next are updates, which is a put or a patch. So depending on how the API was implemented, they can either use a put or a patch to do the update. And that is to replace information about an existing resource. So for example, you can update the borrower's details or change the author of the book. And lastly, there's the delete, which is to remove a resource from the system. So you can delete a book from the library. Next, we have the headers. What is the metadata that you are sending? So headers is used to pass information from the client over to the server. And a lot of these headers, there's a lot of standard headers, but the API, depending on how it was implemented, can also have custom headers. These that are listed here are common ones that you may see, but like I said, there's a lot more standard headers out there. The first one we're going to talk about is the content type. The content type specifies the format of the data of the body. And then next there's the accept. Just like the content type, it is also specifying the format, but it is telling the server what format the client is expecting. These two headers are important because it tells the server and the client how to parse the data that is going to receive inside of the message body. Next is authorization. You will see this a lot because most REST APIs have some sort of authorization as part of the security. Authorization provides the credentials to authorize that request. And we're going to talk about the different types of authorizations later on in this session. And lastly, as part of the request, there's the message body. What data are you sending? The message body contains the data the client wants to send to the server. And because a put, post, and a patch typically sends data to the server since it's creating and updating, those are the HTTP methods that you typically see a message body. Because you're going to be sending data, you need to tell the server what is the format of this data that you're sending, and you will use the content type header like we discussed earlier. Currently, JSON and XML are the typical data formats that you're going to see. There are a lot more data formats available, and therefore that is why you need to specify the content type in the header. Authorization. In order for these APIs to be secure, they need to have some form of authorization. In REST APIs, you're going to hear the term authentication as well as authorization. And the difference between the two is that authentication is providing the credentials of the person making the API request versus authorization, which is telling the server that it has the right to make this particular request. So it is more of an identity versus access. Now let's look at the three common authentication models. The first one being none, which is also known as no auth. And this is typically web APIs that are public and anybody can make these requests. There aren't a huge number of them, but a lot of times there are APIs with no authentication when it is public information. It's nothing that needs to be secure. And most of the time they're typically gets because it is read-only information. Next, there is the basic authentication, also known as basic auth. User name and password is passed to the server in an encoded string. So in the header, what you would put is you use the key of the term authorization, and then the value is the word basic space followed by an encoded string. Basic auth has a standard for the encoded string, and that is of the format username password encoded in base 64. And the last one we're going to talk about is open authorization, also known as OAuth and OAuth 2. This is a standard framework to retrieve access token from the identity provider. The format for OAuth is also authorization as the key, and the value is bearer followed by the access token that's provided by the identity provider. In OAuth, the authorization can be short-lived and more than likely is going to require refreshing of the token. Now let's take a look at an example of the OAuth. So I'm going to go over to my browser and go over to the code exchange page on DevNet. What you will see is that when you try to log in, the different login options are actually not DevNet itself. So you can log in with GitHub, Google, Facebook, Cisco, and the WebEx accounts. Now, when you click on one of them, I'm going to click over to log in with Google, you'll notice that it is going over to a Google site, which is now the identity provider, and it's using OAuth. If I were to provide my username and password credentials, Google will be the identity provider and authenticate whether or not my credentials are correct. And if they are, it's going to go back to the page and provide that access token and give me the access to log in. The next example that we have is a token example. We didn't really discuss this earlier, but tokens are typically used to try out the APIs. A lot of the times you won't actually want to go and implement the whole OAuth handshake before you start knowing how to use these APIs. So if I were to go over to the WebEx APIs and I logged in as myself, you can see that there is your personal access token. And you can use this token, and here you see that it will only be affected for 12 hours, and which is why we're saying that access tokens needs to be refreshed after a certain duration of time. These access tokens become very handy because if you want to try out a lot of the APIs, you can use them without actually needing to go and implement the OAuth. Now that we've looked at the request and the different authorization types that we need to make this request, let's look at the details of the response. The first thing that's probably the more important part of the response is the HTTP status code. You want to know, did my request actually work? The status code is a standard and it is categorized in different types. We're going to only go through a couple of the categories, but there is a whole list out there. The first one we're going to discuss is the 200s. And the 200s are successful responses. So you have the 200, which is a status message of okay, basically saying that the request that you made was sent successfully. A lot of times, if it's a GET and you're requesting some data, you're going to get data back in the response here. Next is the 201 created, where a new resource is created. You typically get this response if you're doing a post because the post was the create CRUD operation. And lastly, for the 200s, there's the 202 accepted. This means that the server received the request and is acknowledging that it received the request, but it isn't done processing the request. Next, we'll take a look at the 400s. The 400s are client-side errors. That means that if you get a 400, you most likely need to look into your request that you made and need to make a change, or else it will not work. If you continue to just keep on clicking to send the request, it probably will not work. So let's start off with the 400, bad requests. The request was invalid due to a client-side error. If you get one of these errors, you probably want to take a look at the parameters, the body, and make sure that it's following the right syntax. Most of the time, depending on how the API is implemented, but if it's implemented correctly, it should send a response back with the 400 telling you what that error was. Next, there's 403 forbidden, which means that it got the request, but you do not have, so your credentials are correct, but then you are not authorized to actually use this API. For example, maybe you're using an admin API, but you're not an admin. Well, it looks like I skipped 401. So 401 is unauthorized, meaning that your authentication was actually missing or incorrect. So you want to take a look at your credentials and see if the username password combination is correct, whether your token was correct, or whether or not you even sent credentials with your request. And then lastly, there's the 404 not found, resource not found. When you get one of these, you probably want to take a look at the URI and make sure that it is correct. The last category that we're going to take a look at is the 500s. 500 means an internal server error. There's something wrong with the server itself. And then there's the 503, which is service unavailable. The server is not able to process the request right now, and you can try again later. Hopefully, the server will send a response back to tell you at what point you should try back. So the status codes are great because it allows you to code against all the different possible scenarios, whether positive or negative. So whenever making a request, you know that there's different scenarios that can happen as a result of it, even if you had it working correctly the first time. There's a lot of things that are out of your hands, such as the 500 errors, and the code needs to make sure that it is implementing those scenarios as well. Next in the response, there's the headers, just like the request. What metadata did I receive? So the headers in the response is information passed between the server and the client. Just like the request one, it can contain custom keys. The header that you will probably commonly see is the content type, specifying what is the format of the message body that the response has provided. There are other headers such as cookies and cache that you may see. Again, there are a lot of different other headers that can be used, and these are just a few of them. And lastly, with the message body in the response, it is what data did I receive from the server? And that contains the data the server sends to the client. A lot of times you're going to get a message body for a get response, as well as error, like the 400s and the error conditions, where it is explaining what the error is. Whenever you get a message body, you will be getting a content type in the header telling you what data format to parse this response. So we've talked about the request, the authorization, and the response. Now let's take a look at the REST API tools that are available that will be helpful for you as you develop using REST APIs. There are many options to work with REST APIs. You can use the web browser, a curl command that is a command line, Postman, which is a very highly used tool with the developers, Python library called requests. We're not going to cover too much of it here because it's going to be covered in Coding 1002. And then OpenAPI or Swagger, which is dynamic API documentation. So let's take a look at the web browser. So here we're going to use an API called the deck of cards. Here you can see all the different APIs that are available in the deck of cards. We're just going to use the first one. So here's the URI for the deck of cards. As you can see, this one's a very simple API. It is a no-auth API, which means that I don't have to provide any credentials. And the reason being is that all it's really doing is shuffling a deck of cards, and there's no harm in that in terms of from getting that information. So if I were to open a new tab and paste the URI here, when I push the return button, it is going to send this API request over to the server and give me a response back. When using Firefox, you can see that it will break it down because the response is in JSON. It's going to break down the key value pairs for the JSON object. You can see the raw data in JSON, and then the headers that get sent. So the request headers were these, and the response headers were these. Using the web browser is typically easy and quick to do it for gets without too many, without any headers or anything, at least custom headers. If you want to get more fancy than that, you probably want to use other tools. So next, I'm going to show you curl, which is a command line interface. So here, I'm going to switch over to my terminal. I've already pasted the URL here, and I had to escape it because of the special characters here. And just like the web browser, if I were to click return, it's going to make the request to the server and give you back the response. As you see, it says it is successful, gave me a deck ID. With this deck ID, there's 52 cards remaining and it was shuffled. Later on, we're going to see curl being used with more headers, and we'll explain that later in this session. So curl can actually take in more parameters than what we saw here, but we just wanted to do a one-to-one mapping and show you that you can do the same REST API request using both tools. Next, let's look at Postman. Like I said earlier, a lot of developers like to use Postman because there are a lot of features that are embedded into here that makes it very easy to use. So in Postman, I'm going to create a new request. If you see here, the user interface is very simple and intuitive. So I'm going to paste the URI here. If you notice that there are parameters in this request, and it automatically created it here. If I wanted to create a new parameter, let's just say the API required other parameters, and you wanted to create it, you'll see that when you type in that information, it automatically put it into the URI. But I am not going to send that because that is not part of the API. Then here on this side, you'll see that there is the HTTP methods available, and you can select it. In our case, it was a GET. You can choose authorization and put in whether it's a basic auth, bearer token, and you can just type it in right there. For this API, we do not need it, and therefore I'm not going to put it in. Then the next one is the headers. You can add in headers and custom headers by typing in that information here. And lastly, there's the body. You can choose what type of data format it is and put in the body here. So when I click the send button, it does the exact same thing of going over to the server, and then it sent the information back over here. What you notice is that you can see the status code, and if you hover over it, you're going to see the explanation of what that status code is, how long it took to make the request, and you can see the headers of the response over here. So in addition to those features and making it very intuitive of how to use it, you can actually save these requests that you made into your Postman, and even create collections where you can group up multiple API requests into a collection and share them with other developers. This makes it easier because then you don't need to type in the URI every single time you want to use it, and it is a lot easier to share with others. And another nice feature is that after making the request, if you click the code button on the side, you can choose different coding languages that are available here to see how to actually make this API request in that particular coding language. Here is how you would do it using Python requests. As I said, we're not going to get into using Python requests here in this session. If you stay tuned for Coding 1002, you'll learn more about it. And lastly, I'm going to show you an Open API documentation. So the WebEx APIs is using Open API for the documentation. And I'm already logged in here. And in the documentation, you'll see the different types of APIs available. If I were to do get my own detail, you'll see on the right side that I'm in the try it, which means that I can make these API requests right here in the documentation itself. So here's the URI, here's the HTTP method. These are the headers. As you notice that the authorization is already pasted there for me because that is the token, my personal access token. And you can fill out the query parameters. If I were to click the run button, I'm going to get a response back with that data. So using open APIs for documentation makes it very easy for developers to be able to use these APIs without really struggling on figuring out, copying that information over to another application, and you can just do it all in one. So now that we've seen different applications that you can use for REST APIs, let's see a request in the real world. I know a lot of people are network engineers, so they want to be able to tie that into what they normally do. So we have an iOS XE device that you can get information from, get the data from. We're going to use curl and get device information. So in this command, you'll see that with curl, we're passing in -v, which means to make the output verbose. I want to see everything that is the request, the handshake, and the headers in the response, not just the response body. Then there's -k, which is to ignore the SSL errors. When dealing with test environments, a lot of the times the SSL certification is the certificates are not valid or will cause errors. And because we're just using a test environment, we're going to ignore those. Then there's the -u, which is passing the basic authentication for this request. It is in username colon password, and this is escaped because we're using curl. And then there's -H, which is passing in the headers. In our request, we are trying to tell the server that we want the format coming back from the response to be application/yang-data plus JSON. So I'm going to go over to my terminal and make that request. I've already pasted it in. And when I click enter, it is going to go over to the system and make the request. So as you see here, if we're going to take a look, so when I made the request, we go over to where the API is hosted, which is at this IP address, and it did the handshake for the SSL. We see the request that is made and see that it's a get. And then here is the response that we're getting back. So we see that we got a 200 OK, and the content type is application yang-data plus JSON, like we had requested. And then it is basically giving me the IP and the net mask of this device. So we broke it down with the response and between the headers and the actual message body. And so hopefully you learned a lot about the REST APIs and have a better understanding on how to get started with APIs. You should definitely use the tools that we've provided you so that you can start making these requests and feel comfortable with making REST APIs. If you want to explore more, definitely check out the Programming Fundamentals Learning Labs. They are self-paced tutorials on our DevNet page. And I hope you enjoyed the session, and I hope you're going to get started with REST APIs.